All right, now to send the filters to the server, we go to vehicle service. In getVehicles method, here we need to pass all these filters as query string parameters. And by the way, I've also done a small refactoring here. So previously we had /API/vehicles repeated in so many different places. Now we have a private read-only field that points to /API/vehicles. So back to this method, first we need to add filter as a parameter here. Now from this object, we need to construct a query string list. So I'm going to define another method here, toQueryString. It gets an object and converts it to a query string. And then here in our getVehicles method, we can append the query string like this that query string of filter. Now I could write this logic inside getVehicles, but that would violate the single responsibility principle. We want to make sure that each method in our application does only one thing. Now with this, if in the future I need to convert another object to a query string list, I have this method here, I can extract it into a separate class and reuse it. So in this method, we're going to iterate over the properties of this object. And for each property and value, we're going to add something like prop equals value in our query string. And then we're going to join all these prop and value pairs using ampersand. So first I'm going to declare an empty array. Then I'm going to iterate over each property in this object. Next, we get the value for that property. So object of property. In JavaScript and in TypeScript, there are two ways to get the value of a property. We can type object dot property using the dot notation, or we can use square brackets. It's exactly the same. Now, if this value is not null and it's not undefined either, we want to send it to the server. Now, you might ask why I didn't use an expression like this, if value. Because the value of a property may be false. For example, we have is registered, that can be false. With this expression, is registered is not going to be truthy. So then we're not going to send it to the server. So the proper way is to check specifically for null and undefined. So if we have a value, then we're going to push a string into our parts array. So parts.push. Now here we need to encode both the property and its value. So we use the native encode URI component function, give it the property, and then append it with equal. And finally encode URI component of value. So with this, we get property equals value. Now finally, we join all the parts in this array and return them. So parts.join using ampersand. Simple as that. Now let's go back to our vehicle component. In ngOnInit, we're going to pass this.filter. Now we no longer need all vehicles as a separate field because we're going to do filtering on the server. So let's simplify and clean up this code. And at the same time, I'm going to remove this field here. All right. Now in onFilterChange, again, we're not going to do this filtering here. Instead, we're going to use our service to get the filtered vehicles from the server. So that basically means we need to copy this code into onFilterChange method. But I don't want to duplicate this, so I would like to extract this into a separate private method. So I would call it populate vehicles. Then extract this and put it here. And in ngOnInit, call this.populate vehicles. And similarly, in onFilterChange, you're going to call this.populate vehicles. So I'm going to select make two. Now we have only one record. In Chrome Developer Tools, under the Network tab, you can see we have a request to vehicles endpoint with our filter serialized as query string. Now here in vehicle repository, I added this extra filter, so we're filtering by model ID as well. And of course, I have added this property to both our filter and filter resource classes. Now currently we don't have a UI for that. We don't have the second drop-down list. And I'm not going to waste time implementing that cascading drop-down list again. However, just to demonstrate that the filtering works, In vehicle list component, in onFilter change, I'm going to temporarily hard code a model ID here. So this.filter.model ID equals 2. So now if I select make 1, model 2 will be applied as a filter as well. So we have only one record that matches this filter. And if you look at the network tab, you can see we have these query string parameters. So make ID is 1 and model ID is 2. And here in the terminal, you can see a log of the query that was sent to SQL Server. So here's the query. We are selecting various attributes of this vehicle. From vehicles table, we're joining it with models and makes. And here's our filter, where make ID equals this parameter and model ID equals this parameter. Now the query generation in Entity Framework Core is improved a lot. And for the most part, you're going to get optimized queries here. Having said that, it's good to keep an eye on these queries. And if you see the query that is generated is not efficient, then you can write your own stored procedure and implement filtering, sorting, and pagination in an optimized way. Now, before we forget, I'm going to remove this line here. So we're done with the filtering. Next, we're going to start implementing the sorting.